and I think this will be the last chapter for this set of notes using Campbell. And then after that, we're gonna go through the past question papers and some other materials which are helpful in the last minute. There is those last minute kind of preparations that you need to get here and there. But I just wanna kindly once more just request or ask if there is no any other question regarding anything that we did last time, or anything that you might be not clear about, or anything that you might want us to start off from, or anything. Anybody? Just show by your thumbs if you are ready to go or you don't have any question. So, which means anybody who's not going to respond, I will assume that they do have a question. Anybody who don't have a question, I will see your thumb on the chat box. So we're going to be going to chapter 4, where we're going to be talking. You remember last time we talked about the chemistry of water, where we were talking about all the characteristics that water has, particularly for life, and how it is structured to support this basic nature called life. So that's what we were doing. And remember this, if all of you, and I'm sure most of you might already have this set of notes in your catalog. You should be familiarizing yourself with one of these concepts. And every now and again, because I'm sure most of you have gone through some past question papers. I've gone through some past question papers. The the concept which your lecturer has highlighted are significantly important for the purposes of your exams. So, and every now and again, when we are talking here, when we are in this session, you're gonna have to watch out or look out for the highlights or the concept that are very significant. The concept that it's a must that when you enter an exam room, you should be knowing those kind of concept. One that we talked about this, and I don't want to go through this, but we talked about concept where we talk about 4 emergent properties of water which contribute to Earth's sustainability, where we explain fully about the cohesive behavior, ability to moderate temperature, the expansion upon freezing, and versatility as a solvent. You need to re-go through this. We explain this in details in further when we continued. I think it was last week, and then we ended up with talking about, that was the last thing that we were talking about. We were talking about the acids, explanation between the differences between acids and bases. What are the units? What are the measures you need to measure when you are explaining the acids and the bases? And how are you supposed to measure those, that pH scale in an aqueous solution? Sometimes if you, for example, there's a 25 degrees temperature where the product of a hydrogen plus or on a hydrogen negative is constant, how is it written? How is it formularized when you use it as a symbol, and how the solution is defined, whether it's negative or positive in that algorithm or logarithm of that hydrogen concentration, and how their symbol is written. And the most significant part when you're talking about the pH scale, we have to be talking about the neutrality. How is it? Because it's the measure or it's the study of balance, where you have to balance. Your pH has to balance. And we talked about how in order for your pH to be balanced, it has to be at 7. That is a very standard measure where it has to be, where you have to find acidic solution, basic solutions, which the difference is that acidic solution have to have a pH value which is less than 7. So in order for your solution to be acidic, you have to make sure that your value is less than 7. For your solution to remain on basic, you have to make sure that your scale has to be actually greater than 7. And how most biological fluid have a pH which ranges between the units of 6 to 8. It will be your pH value in a normal scenario, or in a normal case, will be playing around the units of 7 point something or 6. In a rare case, it will be 5.9 or something like that for your solution to be acidic, and it will not go above 8, and it will not go below 6. And perhaps if it's around 6, it will be around 6 point, above 6.5, when even if you have to convert it for into the decimal factors, it will still be 7. So that's how you need to be balancing your pH value. And we just talk about that. So I haven't really come across a question like this, but your lecturer want to just be innovative, or because there's that element of spontaneous. Every time when you get into an exam room, you should be able to you need to expect the unexpected. There's that one question which will, for some reason, you guys you always have to, every group has a lucky one question which you are the first group out of. You might find that not necessarily that the question was in the last year paper, or the question was in the 2 years paper, but 90% of the questions which are in your exam papers usually are papers which has already been asked in the past, or that they might be reimaging perhaps in a different format, but 90% of the things that you're going to be asked at your exams are things which has been asked before. But there's always one question which has never been asked before. And every group, every year, you have your examiner will give you a present of one question which has never been asked before. So one of the questions that I haven't seen is, maybe he or she could place bunch of food and say you need to equate and check which one are acidic, which one are basic in terms of pH scale, and which one you have to, and then you might have to work around in those. So you might actually have to, even also on your spare time, also when you're researching further, or when you're studying further, also look which type of food are more acidic, which type of food are more basic, and all of that. And that's where we end, where we're talking about the acidification as a threat to our ocean. And I think we did talk about also the buffers, where the internal pH of the most living cells is close to 7. That's what we've talked about. That is a measure of neutrality, where you have to maintain the neutrality. So these buffers act as does internal neutrality, where all the cells have to be closer to 7 or above 7, but it should be in that line of measure. So, and I'm quite sure that most of the reactions, or most of the solution that you're going to be coming across will not be more than 7 or less than 6.8. So buffers are substances that minimize changes in concentration of these solutions, and most buffers solution contain a weak acid in its corresponding base, which combine reversibly with hydrogen ions. So remember, last week we talked about how reactions have to be reversible, and how do you show that a reaction is reversible? What is the symbol when you're doing a reaction which is reversible? We're talking about the products and reactants. You should be able to re-go through all those concepts that we talked about, and you should be pretty much knowing about them. And so acidification, here we're talking about buffers. So acidification, or how is it a threat to so usually they'll tell you, I just want to throw in a question here just to test if you guys are awake or you're still sleeping, by just throwing a very, very young question that we used to even ask when we were doing our first years. We used to ask our lecturers and be like, so you hear in our country, they will always be complaining that there's a water shortages. Like even on places like Eastern Cape, where they're talking about that how uh, uh, they are approaching day zero. If you listen to news, even Western Cape, I think it's a year before. I think in 2021 there were problem where you will hear on the news that they are about to approach day zero. So the my question to you is why don't they Eastern Cape and Western Cape? I'm sure most of you are from Eastern Cape. Maybe there's some people who are from Quebec or Western Cape or who travel there and there to the beaches on the holidays. Yeah, Unisa kids are rich, I had. So the question that I want to throw is why don't whoever who's responsible for whatever use the ocean water for drinking? Like you will see people of Eastern Cape say we are about to approach day zero. The dams are low. There have been a drought. The amount of rainfall this year has been very low. Therefore, people need to use water sparingly because we're about to approach zero. And you're like, you guys are just neighboring to an ocean. Why don't you just use ocean water? So why don't they use that that water? Anybody wanna answer that?
Okay, it is Chanel Rez, and she's saying the cost of cleaning the ocean water is too much.
Yeah, perfect, perfect. That's a perfect answer. But what are you cleaning? You're cleaning what we're talking about. I think it's in your screen. So she's right. The cost of cleaning the ocean water, it's yes, yes, that's I like the approach, all the plastic and pollution and salts in the water. But the biggest one is salt and the pollution and plastic. Yeah. The plastic and solutions people could say, yeah, even our dams are salty and they're polluted and all that. But the basic thing is the salt that to some extent the things water contains a salt which is a sea salt, and that's it's very cost effective. It's very costly. You cannot remove that salt and those acid on those water. So it's but the long and short of it, you are right, it's costly because they cannot remove that salt, which we're talking about, the acidic and basic solution where the pH it cannot be brought into neutrality because of how ineffective that is and how salty the seawater is. So it's one of the best factor about the, if you want to put it like, the naturality of our ecosystem, where you need to give it up to biology. You need to give it up for biology. That there's also something that even some water stream. There are some water stream in rural areas. I know in the north, in the places that I come from, although they are not prevalent, where you've got water bodies, where you get water bodies, it's like a pond. I don't know if you guys know about the natural ponds where culturally, or not culturally, but traditionally, there's this beliefs that if these even these traditional healers, they go there, they if you go and fetch those kind of waters. There's a belief that your things could go well or whatever and whatnot. But because of the modification of our structure and how nowadays people are, the population is growing, there's a land degradation. Some of those are big. But back then, I think before 2005, there were various, I can speak for the place that I come from, there were various ponds which you find that that pond has a salty water, and that pond actually has warm water. by itself. It's just naturally obvious. There's no cliff or nothing like that at all. It's just a water pond. We call it chisima in my language. Then that everyone I know. So you find that that little pond has, it's more or less like a wetland. It's surrounded by a wetland, although terminologically wise, when you're describing every pond, every stream, every water body, it's called a wetland. That's the right terminology. But there is it's not a slang. There is a scientific slang to believe that a wetland is more or less like a riparian zone. The riparian zone, the people who did limnology or water scientists, they will tell you that a riparian zone is when you're approaching a water body or when you're approaching a river, particularly the edge of a river. The edge of a river is very rich. You find that if you've got like um, like if you are plowing something or you are plowing your crops or anything, whatever that you're applying, your sugar canes or anything, and if you plow them on the edge of a river, there's gonna be rich because that vegetation is very rich, it's full of nutrients because it's feeding next to a water body, it's feeding next to a river. So it's very rich. So usually, when you're approaching the riparian zone, there will be a wetland where there are sedges, there are different kinds of plants which are found there. There are different kinds of plants which are very preferable and they prefer those kind of environment and they are rich to those environment and there are trees. Sometimes if you are going up a higher mountains, when you're approaching a stream, you will see about the types of trees that you can find, the canopy that they make. They have like a canopy or a roofing part because they are rich. So those ponds, you will find that they sustain themselves, they have a life on themselves, and also it also has a water body, which that water body which it's it's salty, it's very salty, and it's warm. It's a it's a most fascinating thing. I don't know if most of you have heard about this. You have those in one of your villages, or, or teaching suburb students, where you have the. But I know they are no longer prevalent. But the fascinating thing to me is that they are warm and they are more or less like a pool shape. So if you are in an area where it's a traditional format, like where there's a chief or anything like that, you know, where there's a chief, where if you need to get a stand or anything like that, you actually have to talk to a chief or the what do they call it in English, the gatekeeper or whatever, not the gatekeeper of the what you young people call it on the music industry, but the gatekeeper, somebody who is like the right hand man to the chief, whom if you need a stand, you go to. If you have a funeral in the community, he's like an administrator of the community. So they are the ones who protect those areas, and anybody don't just go there. Kids are not allowed to go there. So that's where they are preserved. They are still preserved in like deep rural areas. And I also know you guys are not gonna believe me when I talk about this. Usually, when a stream flow, but I went once. Okay, let me not use this example because you're gonna say like Mr. Nelfure now is lying in the morning of the 5th of May 2023 when I tried to tell you about a stream that flow in an opposite direction. Because usually a stream or a river, the flow is downstream, isn't it? Somebody just say yes or just show by your thumb. I feel like I'm talking to myself. Yes, thank you. So, so this as and you will see if in your areas also where the I know this. Okay, this example you will understand. When you do a borehole, now there's a problem of water. Some many people are out of the grid of the municipality. They do their borehole. So there are some areas where when after you do the borehole, still that water that you drill, it's undrinkable. It's very salty. It's because you drill deep. I know in Gauteng, because of the fact that the whole of Gauteng is in the surface, because it's a mining province and all that. There's a level that you're not allowed to drill your water to the ground until you're not supposed to reach a certain level, because you get those all minerals and polluted ground. Actually, the whole of Gauteng is polluted anyway, if you ask me. So, but in rural province like Limpopo, Northern Cape, Mpumalanga, when you drill your water, there are some areas where your water will not taste as good as the water that you normally get in your tap. It will be salty. That's because of this acidification. But the threat to our oceans is that human activities such as burning of fossil fuel threaten water quality. So the water quality. So there's a problem of water availability, and on top of that water availability, there's another layer of water quality where the quality of water has to be good. They have to be consumable. Like the people of Hamascrab, they face a challenge where that water rectification plan or whatnot, they get the water on their taps, but when they get the water on their taps, you find that they are not drinkable, they are polluted, they are dirty, like what Chanel was talking about. That there is a cost of pollution which you can, if you've got the proper personnel who's supposed to do the proper job, you can be able to okay, let me check out this comment. It's interesting. Yeah, probably for you to come out and check if the borehole can be drilled on your property. Yeah, and you know what the different what the you should you guys should check on YouTube. There are these people that you're talking about, channel who drill borehole. There, there is what is called a modern techniques to test in your yard. Where can you drill water? Like if Miss Sumaya want to drill water in her house, is tired of municipalities. They're giving her wrong statements and saying you use this amount of water, and she's tired and saying now I need to bore hole, I need to drill in my yard. So there's you need to test in your yard where if you need to bore drill, you will find water very fast. So there are traditional techniques and modern techniques where you do what you call. I was talking about my friend who is actually again a lecturer in university. He was telling me that there are techniques, modern techniques, where they've got detectors where they could come and test in your yard and say, okay, in this side, this is where if we drill, we'll find water quickly. Not necessarily that you won't find water, but you will find, okay, you will find water. There are more water, but those techniques, I think even the modern one still does not detect how long in terms of meters, Chanel, or if we are drilling, is it 50 meters? How 50 meters? I'll tell you why it's important to know how much is 50 meters, because these companies that do the drilling, they will tell you that for 10, if we drill 10 meters, it's gonna be how much? If we drill 40 meters, it's gonna be how much? If we drill 50 meters down, it's gonna be 30,000. If we drill more than 50 meters now, it's certain amount. So the conundrum is to test how much, how long we did. But those techniques tell you where you'll find water, but it doesn't tell you for how long meter. But it's very go into YouTube, all of you after this session, and check the techniques to test the water. If the water there's water, they use sticks. You can just go and use sticks. You can hold sticks and make a cross and walk straight, and there will be like a force which will, if you're holding it, if you're holding it rigidly and holding it so strong, you will just feel the force if you're doing the force pulling you down, pulling that sticks down. if you just make the cross. It's so fascinating that the traditional techniques to test if there's water in your yard, you can try it if you check it on the YouTube. If you've got sticks after the session, you will see it is very fascinating and very thrilling. So there are ways to check. There are techniques to also test if there is water in your areas. But those techniques, even the modern techniques, the disadvantage is that it does not tell you for how many meters when you drill those waters are, but it just tells you that there's water. But again, in terms of the water quality, is that you find that sometimes those waters that are found there, they still have a lot of acidic solutions. They're still salty, so their quality is still compromised. So carbon dioxide is the main product of fossil fuel combustion. We know about that. Those of you who've got cars, and about 25% of the human generated carbon dioxide is absorbed by the ocean. So that pollution that you were talking about, Shana, the 25, imagine 25% of all the pollution that is generated. And who is the generator? Who is the number one culprit? It is us humans. Is absorbed by the ocean. And carbon dioxide, which is dissolved in seawater, form a carbonic acid. And this is the process which they call ocean acidification. So they might also one of the reasons why the water in the sea is not in good quality to be drinkable or to be consumable. You might actually have to say as one of the reasons is that there is also ocean acidification, where this carbon dioxide is dissolved in seawater and form carbonic acid, where this carbon ocean acidification is the reason why this water is not consumable. And this is also illustration of these formulas where you see these people, most of you are going after you pass your exam. Your family say, let's take off. We're going to Thailand. We're going to Mauritius. We're going to wherever. But yes, we know that UNISA students, you're going to be celebrating, but there is CO2 that you are consuming, which is being also absorbed by the ocean. We talk about carbon dioxide plus hydrogen ions, and all this, which are, and now what's happening? The sea life is being destroyed. The sea life, and you know what they say, that there is more life on sea than on land. Most of the species, most species that are in the sea compared to that which are in the land. And you know that there's a fun fact which says every the Doppler, every species which is on the land, it's in the sea, but not all the species which are on the sea are on the land. So this is some sort of debacle that we face. And I see water acidifies. What is acidifies? We're talking about the solution, which have a p value which is less than 7. So we're talking about, and when I have to think about the basic solution and acidic solution, when we talk about that. Anyone? Is that a question or anything like that? No? Okay. So seawater acidified these hydrogen ions, which combines with carbonate ion to produce bicarbonate, and about that. And this bicarbonate is required for calcification, which is the you need to highlight and know what is calcification is. What is the procedure for calcification? Uh, which is just the production of carbonate. So that reaction, and you need to, like here when we talk, you can check, is there a reversible reaction here? Anyone? You can just type yes or no in your chat box. Yes, no, yes, no. Is this reaction reversible? No, thank you. Somebody else no, answer no. And so this carbonate is required for calcification by many marine organisms, which include reef building corals. This organism and so this is just to just check the balances in the oceans, lakes, and rivers. So the water which is consumable is the one that we find mostly on the rivers and on the lake on the dams. But because the streams, the flow of the streams that the water bodies will move from those the streams of rivers all the way to the dams and all the way to the oceans. And then when we go further, so this calcification rate, there's what's called calcification rate, where is the effect of calcium carbonate saturation in the state of calcification for the coral reef is just an animal where a marine animal of the current coral reef. So this calcification rate where it's measured in the micromolecule uh, for per kilogram of sea water. This is the measure of rate, and this is the number of calories, but you don't need to worry about that. And this is just a diagram where it's just showing the rate, the effects of rate, calcification rate, and the number of this coral reefs which is affected in the experimental measure. So you don't need to worry much about this unit of diagram, and this is just an illustration of those coral reefs. And we talked about the acidic and basic solution, and we talk about the neutrality. The neutral value is it's 7, and the basic gravitate toward the unit of 14, and acidic decrease to the value of 0 from 7 below. And it's just a little fella here, which is saying, is there any question? But I like how the question start. The question starts by saying, I got here late. uh, so I wanted to know if we should use that. Yes, you can use them. You can use them, and I'm sure we will. I don't mind you using them. I'm sure Miss Maya will. If you don't have them, you just talk to her, then I will. Usually the materials that I'm using are in your tutorial letter. So those tutorial letters have okay, is it going to be set up as a quiz or no, what I'm gonna do is I'm gonna these notes that I'm using, the slides, you are more than entitled to and welcome to have them, and they will be helpful. So I can assure you, I cannot assure you that all the things that they will be in the exam, but 80% of the things that actually, let me see, 90% of the things that we're gonna do that you'll find here are what your examiner will extract the question from it. So it's gonna be very helpful. So the notes that we're gonna give you here, if you go through them and also go through also some past question papers and other study materials. But all the materials that you need are in your link there. There's a link in your I don't know, Miss Sumaya, if they receive the same type of documents that I received, but in those links which shows the where you can access the textbook, like the one that we're talking about, the Campbell and others 2015, if you haven't access to it, which they show the link, the only thing that you need to have is just details which your university can be able to give you. Sarapo, you answered? Okay, thank you. Yeah, but more the whole thing that we are using, you can relax. She will send it to you if you don't have it already. But usually I prefer to give the notes that I'm using at least after we have stopped or we have finished with the session. So here we're gonna be talking about the carbon. You can see there's a little bit of a chemistry which is ensued or which is underneath our biology. Then so carbon is the, if they have to explain it, is the backbone of life, where living organism consists mostly of carbon-based compounds, and this carbon are unparalleled in its ability to form these complex and varied molecules. And when we talk about proteins, DNA, carbohydrates, and other molecules that distinguish living matters are all composed of these carbon compounds. So, like this little fella here will explain why he's here. So, the organic chemistry is the study of carbon compounds. The study of carbon compounds when you talk about organic chemistry. So, in terms of terminology, this is one of the concepts that you should look up to. Is the study of compounds that contains carbon regardless of origin. So every element or every unit that will contain or that will have the compounds containing this carbon, regardless of whether they originated from which side or which factor. That study is still under the discipline of organic chemistry. So organic chemistry have organic compounds which range from simple molecules to colossal ones. We'll explain further what we mean by that. And when we talk about organic molecule and the origin of life here on Earth, that's scientist Stanley Miller's who did a classic experiment to demonstrate the abiotic synthesis of organic compounds. When you talk about abiotic, we're talking about factors which are non-living factors in simplicity, abiotic factors. So they are demonstrated by abiotic synthesis of organic compounds, where this experiment that he did supports the idea that abiotic synthesis of organic compounds, perhaps near things like volcanoes, will have been a stage in the origin of life. But the main big factor when you talk about Stanley classic experiment, you need to know or you need to underline that is based on the idea of abiotic synthesis. I'm muted. Not biotic. And is there a question? Sorry. No. Okay. So not biotic. So you might find that sometimes your lecturer or he or she on the exam or on the quiz or wherever, they can throw in a question or two there in one word terminology, and if they say biotic synthesis there, it's a whole completely different thing. But you need to underline or make sure that the what we are talking about the abiotic synthesis, which is formulated from abiotic factors. Which are abiotic factors? What are the, if you can just give like five abiotic factors? Anyone? Disadvantage in mind. when I'm using PowerPoint is that I cannot see the notes or the question on my screen. Anyone?
Soil.
Which one?
Soil.
Soil. Okay, cool. One.
Precipitation
Good.
and sunlight.
Yeah, that's basically yeah. So abiotic are factors which are you can say they really not I don't want to say they are not alive or but you could talk about things like you mentioned those you can talk about things like what we're talking about just now, the pH, the humidity, the soil. You mentioned the soil. You talk about the precipitation. You're talking about like rain or water is yes, and you talk about the salinity, which is more or less the same as what we were talking about when we talk about the pH, also the minerals and the temperature that we find about and how all of these are affected in terms of these abiotic factors. And the diagram that you will find very common in most of the cases is this diagram where we're talking about the sample for chemical analysis. So where you see this arrow, which is just showing the the idea of how the flow is. We'll talk about water vapor, we'll talk about atmosphere, electrode. There are these elements here which are condensed here, and sometimes the water that goes out, then the water that comes in, which is cold water, and the cooled here by those organic molecules, and then it goes here, and then this is the kind of more or less like the experimental that they did, which is doing the flow chart, but you don't need to worry about this diagram. For the overall percentage of the major element of life, the carbon, hydrogen, oxygen, nitrogen, sulfur, and phosphorus, which are quite uniform from the one organism to another. Why? Because this carbon ability to form four bonds where these building blocks can be used to make an inexhaustible variety of organic molecules. So that's how they can be quite uniform in that form. And also that the great diversity of organisms on the planet is due to the versatility of carbon. So this carbon not only is it essential for life, but it's also uh, essentiate or is the essential universality that necessitates the diversity of all the organisms in our planet, they say. These carbon atoms can form diverse molecules by bonding to four other atoms. Where we talk of when we're going to be talking about the electron configuration, which is the key to an atom's characteristics. And also, where you're going to be talking about the electron configuration, which determine the kinds and the number of bonds this atom will form with other atoms if we are talking about the configuration to form these characteristics. So the formation of of these bonds with carbon is that with four valence electrons. We talked about the electrons, how they are being formulated, and you when we do some past question papers, there are some questions which will request you to just in an atom or in an electron, which will to 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 show or to see which one are the electrons, which one are the neutrons, which one is the atomic number. Sometimes they will request you to calculate the atomic. So they will not necessarily say calculate, but they will just give you a multiple choice question where they will say in this between these four molecules or between these five electrons, this one has an atomic number of such and such. So you're gonna have to calculate and that to get the atomic number. How do you get the atomic number? How do you and because the large complex molecule is possible when you talk about the formation of bonds with carbon in molecules with multiple carbons. Each carbon is bonded to four other atoms and has what they call a tetrahedral shape. But when two carbon atoms are joined by a double bond, the atoms joined to the carbon are in the same plane or are in the same format as those carbons. So here is just an illustration of this elements where you find that here is the I'm going to show the molecular formula, the structural formula. You don't need to worry most about the stick model, this model, but like I've mentioned in the past, that you might actually have to very be pay much attention to the formula and the molecular formula and the structural formula. This is the element or the formula of a methane, where is CH4, and ethane, which is C2H6, and ethylene, which is C2H4. And this is the formation of the bonds where you have to illustrate how they are bonded in terms of their structural formula. If there are double bond, if there are single bond, if they are covalent bond, if they how the structure of their bond is. But I don't necessarily think that your examiner will request you to draw the bonds, how the bonds are. But the formulas you must know. And also the structural formulas you should know, because he may not request you to draw the structural bond, the structural formula of ethane, of carbon dioxide, or how they are bonded, how they are equivalently bonded, but he may say this is the structure of an ethane by form of structural bond. So if you don't know the structural form of ethane, then you have to choose, or you have to equate it to the right choice. And if you don't know them, you might find yourself that he got you in the corner. So you have to know which are the structure, and also not only to these ones which are here, also to others. So when you're doing your notes, also check about other molecules and check their molecular formula and check the structural formula. So the number of unpaired electrons in the valence shell of an atom is generally equal to its valence. So what the number of, we talk about the covalent bonds, well, the number of covalent bonds it can form. So these unpaired electrons in the valence shell of an atom will have the number which is equal to that, which is equal to those of oh no, which is equal to those of its valence. So therefore, the number of covalent bonds can actually be formed in those valence electrons. So here is just an illustration of an example where we talk about hydrogen, and then we talk about oxygen, we talk about nitrogen, we talk about carbon, where you find that the valence here is one valence electron. We'll talk about the unpaired electrons in the valence shell of an atom is equal to those of a valence, where the number of those are covalent, it can generally form. So if you check here as an example, this one hydrogen has one, this oxygen has 2, and this one has 3, and the carbon one has 4. And we will explain further what it means. So at the electron configuration, excuse me, the electron configuration of carbon gives it it gives it a compatibility, that the idea that it can be comparable, or it can be compared with the different elements and the valences of carbon and its frequency partners. What are those partners? Hydrogen, carbon, oxygen, and nitrogen. Think of this that we talked about when they give you here the overall percentage of the what they call it as the major elements of life. It's carbon, hydrogen, nitrogen, sulfur, and phosphorus. So where their partners, but here they will call it frequent partners. Talking about hydrogen, carbon, hydrogen, oxygen, and nitrogen, which are the building codes for the architecture of these living molecules, that they're just the basic structures or the basic molecules. And then carbon atoms can partner with atoms other than hydrogen, such as the following, which is carbon dioxide. When we talk about 1 carbon, 2 hydrogen, you see how they're partnering. And where the stock of atomic number, the valence electrons, the number of electrons, the number of neutrons, and this they are bonded covalently with the double bond and the strength of those partners. It's also carbon dioxide, it's urea, which is CONH2, which is, you see their structural bond. The carbon is it's because these are the atoms which the carbon can partner with, and also the urea, or the carbon, which is nitrogen, hydrogen, which is single bonded, and some instant covalently bonded. The molecular diversity arising from variation in the carbon skeleton. Is there any question again? Cannot see my. Okay, now I can see my comment. Any question up to so far? Let me check on the comments. Still nothing. All right. So molecular diversity arising from variation in carbon skeleton is just that carbon change from this skeleton of the most organic molecules, where these carbon chains vary in their length and shape and their distances and the structural formation. So their structural forms are differentiated with the and usually they don't call it. Sometimes they'll call it skeletons of the organic molecules, where they will be differentiated by the length and their shape. And you can see here where they're talking about the differences in the length, in the double bond position, in the branching, in the presence of rings. So you can see here that in terms of the length, there's a difference. This one is between ethane and propane, which is a bit, if you did a little bit of chemistry in high school, you will remember this one. They were talking about the bonds and the length and the double bond position. You can see here, so the butene and 2,1, you see here, it's in the position, it's in the first position. This one is in the second position. And in terms of branching, you can see this one doesn't have a branch, it's a single strand. This one here is branched. And the presence of ring, you can see here that it's ringed, and in the cyclohexane and in the benzene. The length here is just an illustration of the length is, where you can see that here is a little bit less. Also, the structure of the presence of ring. So this is the carbon shape, or the scientifically description, you call it carbon skeleton. And we're gonna go further to the hydrocarbons. Hydrocarbons are organic molecules consisting of only carbon and hydrogen. And also, when you are giving one term, you need to be extra careful with the terminology and how you describe this, because they are saying it's not organic molecules, not molecule, but organic molecules. So you're gonna have to pay attention to terminology, which are the discriminative factors, which describe or which discriminate or which outline itself from others. So yes, it may sound like it's very common, it's very self-explanatory. We say a molecule consisting of only carbon and hydrogen, but we're talking about only organic molecules. And these organic molecules, such as fats, have hydrogen components, and these hydrocarbons can undergo reactions that release a large amount of energies. We'll talk about fat droplets. This is just an illustration of a part of a human death-exposed cell. We'll talk about the fat molecule, not fat. Here is the nucleus and the 10 micrometer, and how they undergo the process where they release a huge chunk of energy. And this is just another description of illustration of the human adipose cell, but you don't need to worry about that, because you don't need to view it as the moment, as the form of microscopic view. Then we go forward to what we call isomers. So the isomers are compounds with the same molecular formula but different structure and properties. So here the trick is that you will come across terminologies or terms which have description which may sound very similar, and you will understand when we proceed, but they have rather few distinctive or different description, or very few concept which differentiate them, but they sound or they look very similar. So when you go through this terminology in your studies, you're going to have to pay extra attention with the differences. How do they do? So these isomers, they have the same molecular formula, but their structures are different and their properties are different. And the structural isomers have different covalent arrangement of their atoms, which there's a cis-trans isomers, which have the same covalent bonds, but they differ in their spatial arrangement. And there are somebody will have to read this terminology for me. I tried to read it even yesterday. Enantiomers. And somebody read it for me. Anyone? Kanye? Latoya? Miranda? Odani? Anonymous. I don't know, like that. All right. Thank you.
Enantiomers.
Thank you. At least there are people who are not sleeping. Then here's the difference. We talk about structural isomers and cis trans isomers and yeah, enantiomers. Here is because they're saying these are the data. They are just like mirror images of each other. You understand? And these ones, the trans ones have the same covalent bonds, but they differ in their special arrangement. And the structural ones have different covalent arrangement of their atoms. So have that structure when we go to this diagram. So pentane and methylene butane are structural isomers. Why? Because they have different covalent arrangement of their atoms. Yes, these ones are branch, these ones are just ring. Enantiomers, the one that we talk, they just mirror images to each other. Then the cis trans, what did they say? The cis trans have the same covalent bond, but differ in their spatial arrangement. So you find that they are covalently bonded, yes, but they differ in their spatial arrangement. That here you can see this little solar hydrogens are here on this. They are arranged in a same side, but here the axes are arranged on the opposite sides. And this then again the explanation of structural isomers, and again the explanation of the cis trans isomers, where the cis isomer, the two axes are on the same side. We mentioned that and the two axes are on the opposite side to one another. And this one that the mirror images of they're the images of each other, what is L isomer and the D isomer. And this is just another animation. We talk about the enantiomers and geometric isomers. By geometric isomers, they will be talking also about the cis transformers. You don't need to worry about that, but you will have to use cis trans isomers. But in some cases, if they use geometric, they will be just referring to cis transformers. And it's another just illustration when they are showing their arrangement, how their arrangement is in the geometric formation. So just know that when they're talking about geometric isomers, they are referring to cis transformers. These enantiomers are important in the pharmaceutical industries because the two enantiomers of a drug may have different effects. Usually, one isomer is biologically active and the other may not be. So, the differing effects of enantiomers demonstrate that organisms are sensitive to even subtle variation in molecules. So, this is just an illustration of the type of pharmaceutical effects that they use in the drug, where they use it to remedy any sort of diseases which might be there. But you don't need to worry much about this, about the health of. But the question that they may just throw in is that why are enantiomers important? So you will have to explain that. They are very useful in pharmaceutical industry. When we talk about pharmaceutical industry and the drug industry, it's a matter where you're talking about the medicines and kind of medicine that they will be using in order to actually remedy, some kind of any solution to any disease or whatsoever. So that's how, or that's where they are used. Or if they ask you, explain how in enantiomas are used or useful. How are they useful, or why are they useful? Need to illustrate that they are useful, and they are very important in the pharmaceutical industry. That they are the product, they're the one that are used to produce medicine. They're the one that are used to produce drugs. The drugs, they don't mean the drugs in the street. Like, so you can use the drugs which are useful in the medical industry. So where we talk about the L-DOPA and so chemical groups are key to molecular function, where if we dig into distinctive properties of organic molecules, which may depend on the carbon skeleton and on the chemical groups which are attached to it, and the number of characteristic of group can replace the hydrogen attached to those skeleton in those organic molecules. Then the chemical groups of most important in the process of life, where we'll be talking about these two fellows here, estradiol and testosterone, which are both steroids in a common carbon skeleton, which are in the form of four-fused rings. And these like hormones, they differ only in the chemical group which are attached to these four-fused rings in the carbon skeleton. Then if we talk about this estradiol and testosterone, which could be the common group of carbon skeleton, which are in the form of four rings. You can see here that the estradiol have a single bond of hydrogen oxygen and the CH3, and the testosterone here is got oxygen here, CH3 and CH3, and then OH on this side, where you can find how they are useful or made up. Therefore, the functional groups are the components of organic compounds, or of organic molecule rather, which they are used. They are used and they are most commonly involved in the chemical reactions, which these components belong to, and the number and arrangement of functional groups give each molecule a unique property, which is more or less like a barcode sort of a thing to say if you wanna evaluate the arrangement or the number of those functional groups which are there. So these functional groups, or these functional components of organic molecules that are involved in chemical groups, there are 7 of them which are the most important in the chemistry of life, which are the following: the hydroxyl group, the carbonyl group, the carboxyl group, the amino group, the sulfuric group, the phosphate group, the methylene group, which have their effects. So this here you just need to describe them and know them. It's how much is 1, 2, 1, 2, 3, 4, 5, 6, 7, and this chemical group, where it's just a group property, where you talk about the examples, where hydroxyl, where we talk about alcohol as a group property, and the carboxyl group, carbonyl group, we'll talk about you see even their structural formula. This is the example right here of an ethanol. And here, when we talk about the carbonyl group, we talk about the carbon and the oxygen, and the group which is ketone and aldehyde, and the example there of an acetone and propanol. So here, when you talk about alcohol, I think when we did our chemistry in high school, I think by now we know that what we drink, I don't drink, but what you drink, don't drink because I think alcohol is expensive. So you guys will drink you actually what you're drinking. You're not drinking actually the actual alcohol. You're drinking part of added alcohol. So you cannot see you're drinking ethanol or you're drinking alcohol. This is an addition of alcohol and also the carboxyl group, which is covalently bonded with CWOH, where you can see here, even that there are a group of bonds and the group properties is carboxylic acid or organic acid with the example of acetic acid and the amino group acid where you talk about an H2. It's an amine. I don't know much about the if the amino acid also belong to this group property. And also in terms of an example, you can see there's a glycine. And here, uh, also here and then on the acetic acid, the different enough or the interesting part is that it's also the one reaction example which is reversible. You can see by the representation of double arrow right there, and then the sulfur group, which is CH, when the group belong to thiol, and the example is cysteine. Cy is the cysteine, yes. And then there's one common popular group called phosphate group, which is described here by the structural formula of OP32 there, and then the group belong to organic phosphate, and the example is glycerol phosphate. And also you see the last group with the methyl group CH3, where there is a group is a methylated compound, and the example right there is a 5-methyl cytosine. And another group here where we talk is just so much what we're talking about. Yes, it's just that it's here in the zoomed in a detailed manner. Where, yeah, probably to electronegativity organic oxygen which form hydrogen bonds with water, and the name of the compound is alcohol. That's what you find in your in your beverages that ethanol. So per se, somebody cannot say if somebody say you're drinking ethanol. No, the alcohol which is just present in alcoholic beverages, it's ethanol. Pretty much diluted because if you drink the whole of ethanol, it will be just to most of you. And another group which is a carbonyl group, which is a example of a acetone, which is the simplest form of ketone, and also the propanol of an aldehyde, where we're talking about sugar products with ketone groups, which are called ketones, and those with an aldehyde, they are called aldoses, which the compound name is ketone or aldehyde. So the common example, one of the compound which is known is it's sugar, a carboxyl group, which is example is acetic acid, which gives things like vinegar and its sour taste, which we're talking about, and also it's in the form of ionized form, which is in the CWOH, which is carboxylate ion, which is found in the soil. And the most common example are acid, which the compound name is carboxylic acid or organic acid. And the other one is amino acid group, which is NH2, which is glycine, and amino acid group, which is noted as carboxyl group, and they are in the form of ionized form in the NH2, which is found in cell. And the most example is it acts as a base. You remember that the one that we just come across is that carboxyl group. If you can compare it to amino group acts as a base, and carboxyl group acts as an acid, and the compound name for carboxylic group is it's carboxylic acid or organic acid, and the one for amino group it's the compound name it's acid, it's amine rather, sorry. Yes. So also when you go to sulfur group, which is CH, which the example is cysteine, and which is a sulfur containing amino acid, or we talk about 2SH or sulfur group, which can react from cross-link, which helps stabilize the protein structure, and their compound name is and their compound name it's organic phosphate. And the compound name for sulfur group it's style. I will tell you why I'm going through this again. And also the phosphate group has OPR, which is I think is the last one, which is the example is glycerol phosphate, which take part in the many important chemical reactions in cell, and they contribute negative charge when attached to confers on the molecule, which is the ability to react with water and releasing energy. And their compound name is organic phosphate. Oh, and there's an methylene group, which is CH3, and the example is methylene suicide, a component of DNA that has been modified in addition to this methylene cytosine. So their function is that it affects the expression of genes, and it affects the shape and function of a sex hormone. And the compound name is methylated compound. So the ins and out of this is that when you are describing these groups, these 7 groups, they may say describe them, the chemical groups, and also name their examples, and also give their compound name, or give their functions. So this question might be how can I put it? It can actually be an involved question, which is extended. And given what I've seen in your past question papers, there are some questions which, if you, I don't know how to say this kindly, but if there are some questions that if you don't have a clue, then to use your clinical term that you use in the street, you are screwed, because there are questions that he, like this diagram of these 7 functional groups. This is something that you just need to make sure that you know them, you know these groups, you know these diagrams in and out, especially here when they are explaining. Because for an example, if he says give at least 7 functional groups and also describe their properties, and also give their example, and also give their functions, and or maybe he doesn't say that they give their properties, or he said list 7 functional groups and list their compound names and give their compound names and their functions. So it's already 7 times 3 in one question. Okay, in one question. There are some questions where this kind of questions about the functional group, it can come as a question on its own. What do I mean by that? You could say, let's say you are in 10 questions where there's question 1, 1.1, 1.2, question 2, 2.1, 2.2.11, and whatnot, and question 3, question 4, where in question 6, you could just say it's about functional groups only. And there is no beating around the bush. You just like list 7 functional groups and describe their compound names, describe their examples, and also describe their functions. And you're gonna have two. For hydrogen, you're gonna have a compound name. It's compound name and a group properties are the same thing. So that shouldn't act as a confusion. But when you go through the notes, when you go through this note, you will be able to tell that, oh, when you talk about methylene, a group is talking about methylene alcohol. When you talk about the carboxyl group, where is carboxyl group right there? Carboxyl group is talking about carbolic acid. When you talk about amino group, it's talking about the basic. It's talking about amine. And I have to also give the function here. I have a good feeling that it's gonna, because also the function we're gonna have to, for hydroxyl group, we're gonna have to tell us that yes, because the electronegative oxygen, it form hydrogen bonds with water. In as far as this is concerned, it's just you're gonna have to tell us what is in the notes, what is here, and this is just a matter of the fact that you go through this and make sure that you know this in simple terms. I'm saying this, you don't want to miss this session. I'm speaking to someone now. I feel like I'm in church. Just show by thumb if you are following, or thanks. So as we continue, don't miss this one. So an important source of energy for cellular process is we talk about the ATP. We are talking about the source of energy. We're talking about the powerhouse now. Talking about the where the nutrients are structured in, where they are. So an important source of energy for cellular processes is that an important organic phosphate is ATP. What is ATP? It's also, forgive my pronunciation again, it's adenosine triphosphate. So this ATP consists of an organic molecule called adenosine. So this so adenosine is actually how much do I have in the battery? Okay, I think we manage. This adenosine is it's actually an organic molecule. I told you when we were describing that you're gonna have to describe and be distinctive about the fact that if they're talking about an abiotic, not biotic, abiotic synthesis, and also you're gonna have to be careful when you're talking about the organic molecules, because it's a descriptive factor, or it's a descriptive a discriminator, or which outline the certain aspect or compounds in that molecule. So this ATP consists of an organic molecule which is called adenosine, which is attached to a string of 3 phosphate groups. We'll talk about that when we go further, where this ATP stores the potential to react with water, and this reaction releases energy that can be used by that particular. So this adenosine, which is an organic molecule, so to react with water with the 3 phosphate groups, where you can see here it's adenosine, where you see the P, and this 3 oxygen, which are group and do so on. So this reaction here of triple P adenosine, which is ATP, which reacts with water. They have explained here that ATP store potential. It stores the potential to react with H2O, and this reaction releases the energy that can therefore then be used by a particular cell. And then the adenosine, which will react with water, and then the organic adenosine, which is adenosine ADP, plus the inorganic phosphate, which is going to give blood energy, the energy which will therefore then can be utilized by a particular cell. Then the chemical elements of life as a review is the versatility of carbon, which makes possible the great diversity of organic molecules and the variation of those particular molecules, which is at a level which lies at the foundation of the biological diversity. And here is the just it's derived from the data from studied by Parker and others, which was titled The Predominant Scientists of Amines and Amino Acid in 1958, Miller H2S rich spike discharge, which is in the Journal of the Proceeding of National Academy of, you need to check. But the issue here is that the differences in the product compound and molecular formula and the ratio. Don't need to worry much about the ratio, but also you can know if the compound. All right, let's so the product can you still hear me? Sorry about that. Just show by your thumb. Yes, you can. So the eventuality is that when you also talk about the product compound, the molecular formula, like I said, you don't need to worry yourself much about the ratio, but the glycine, serine, you just know the formula and the molecular formula, and the methionine align, which is 3C3H7NO, and then 2 oxygen and C5 carbon, hydrogen, and 11 hydrogen for methionine, and 1 nitrogen, and 2 oxygen, and 1 sulfur. And also that's the case also to the steroid. So you need to familiarize yourself with the molecular formula and the product compound, but you don't need to worry yourself much about the structural formula or the ratio. Structural formula is a different thing, but the molecular ratio, then you don't need to worry yourself about this, the L-dopa, and then these fellas here, they just ensure you to see what's your question. But it's very significant that you understand the concept that we were using, that we were tackling, especially the about the structures of life. Oh, this needs me to sign in. I need to access some of your study materials about the concept that it's very significant, and I want us to revisit it in the absence of the question, because I know that in a far as that you might actually not have a question, but I think I have to revisit it with extra comparison of the notes. So most of the time on the study materials that they have given you, right, there will be links of there will be links where you can access the notes from. There will be links where you can be able to access the study materials, which is very proactive and very useful. So that's what I'm doing right now. So I know that most of you have access to. Okay, I just want to assume that most of you have access to internet. So I don't know how prevalent that is, but I'm still also technically a student. Also, I get the the the, the access to data. So I want to show you how you can be able to access this study materials. But what I'm looking for, I cannot finding it. Sorry. Here we are. In the unit of prokaryotes and evolution. But I know those of you who are attending also BLG1502, we touch a bit or a lot with regards to prokaryotes, differences between prokaryotes and also eukaryotes, how they differ. But I want to revisit the evolution and Galapagos concept, because your lecturer here, he has also outlined the very useful aspects or links which you can be able to access, like the question that who asked about the study materials, where you can access more of the study materials in your notes. So here in this notes that you're gonna find, it's I want us to quickly go to focus on the unit of comparison between eukaryotes and prokaryote cells, which we didn't touch in details here on this unit, but I thought that we're gonna focus on evolution, but the evolution one, it's quite broad and I don't think we'll be able to cover it today, and I don't want to touch and go for that concept. So the thing that I want to show you, particularly on this, because this is a Word document, so usually he will give you your notes like this, and then where he will be requesting you to compare to the characteristic of the two types of cells by writing them. So the extra input or the extra effort of the study materials, which I don't know, sorry, I forgot your name. You ask about what the questions will be about or what we're going to be using to study. Here is another link. You guys can see the link here. You can just, so here is a link where you're gonna go through the link and you're going to use your credentials, your university credentials, to access the book. And then this is the description where there are other materials in the form of a book or in the form of an article, paper article of a journal, which most of the time, the one that he had outlined here are specifically accessible to us. You don't necessarily need to buy them or have to have as some sort of a permission to get them for that way or the other. So that link will take you straight to those particular nodes, and this where just hold on a second. Sorry about this. So where you're gonna have to find the differences between the prokaryote cell and eukaryotic cell. And we did talk about this in BLG1502, but I want to talk about it in detail here. So what I'm going to do here is going to come here. Hope this is going to work. So we talk about this link, right? I'm going to go and click on this link here. And I'm going to stop sharing so that I'll show you where it took me to. This is where you're going to have the access to extra study materials that we might not actually distribute those kind of extra notes, but you'll find that where the notes that your lecturer could derive from, which are very significant and very important. So this is where it's very slow. This is where the link will take you, where we're going to be talking or showing you the differences between eukaryotic cell and prokaryotic cells, where in terms of structure, where the nodes are derived from. Hopefully I can be able to do this. And you can see, I think on BLG1502, we talk about the distinctive between the species, where we talk about the fact that the prokaryotic and eukaryotic are considered to be the most important distinction among the groups of organisms, and where, if you can just check here, there's an element of similarities and the differentiation, where we talk, oh, look at yes. You can see that also I also struggle with my sorry guys, it's very slow. Where you can see this is the image of a prokaryotic cell. I think we had one of these in the previous in BLG1502, where we were talking about how the differences between the prokaryotic cell and the eukaryotic cell, and that the eukaryotic cell has a cell wall, plasma membrane, cytoplasm, ribosome, and plasmid, ribosomal, and villi. Where we're talking about this flagella and the nuclei, which is circular in the DNA. And here is if you wanna accumulate this image in the form of image, you can use it. And then also, if you wanna accumulate it in the form of a PDF, you can do that. So this is where the link. This is where it will take you, the link of your lecturer. Why am I saying this? It's important because most of the stuff that we're gonna come here, I translate it or I accumulate it and put it in my slides. So, but some of the extra inputs, you will find that you're gonna have to contain them from those links. So those links, you don't have to ignore them. You need to make use of them very well. Am I making sense? Yeah, so I cannot stress this enough, that it's very important. So that the most detailed the most detailed study materials are contained in those notes. I'm sure we're gonna distribute those notes, which has in Word format, but they are like a skeleton, blue skeleton, which has to be fed the meat by the links where you're gonna have to go and extra mile for a type of a paper that you're gonna have to read, and also the link that you're gonna have to show to. Why am I saying this? I'm saying this because starting from next week, I think in BLG, I'm gonna be focusing more on the previous question papers in an hour, and also another hour we're gonna be doing the notes. So we might find that we don't have an nitty-gritties of the time where you guys have to actually go through and show the formation of more study materials upon yourself. That's what we call you that's what you call you don't have to, what do you call them? They will say we don't have to give all the information or spoon fed all this thing. But in the interest of time, can I ask you guys if you've got any question?
All right, the student is asking, is there any way that they'll ask us to draw the actual structural formula? Are they going to be shared before the examination? Now, from my own experience and my own examinations, I would say that go over the previous exam papers. The lecturers normally post them on your MyUnisa, and there is where you will see what will be shared and if there will be a actual drawing or just the labeling required. Should we say yes? Obviously, we will not know which drawing, but your past examination papers go at least 2 years back or 3 years back and check those. And in all likelihood, it would then be that the drawings that you might have to label or you may have to draw. So look at that from my own experience. That is what I know. Thank you.
Any other question? I think that you answered very well. Yeah.